want this to feel real, so we'll work on something fun, a social networking application. Shouty is a social network that allows people who are physically close to communicate, just like people have always communicated, with their voices. In the real world, you can talk to someone in the same room or across the street, or even 100 meters away from you in a park. If you shout, that's shouty. What you say in this social network can only be heard by people who are nearby. Let's start with a very basic example of Shouty's behavior, something we might have discussed in a Three Amigos meeting. Sean the shouter shouts, "Free bagels" at Sean's, and Lucy the listener, who happens to be stood across the street from his store, 15 meters away, hears him. She walks into Sean's coffee shop and takes advantage of the offer. We can translate this into a gherkin scenario so that Cucumber can run it. Here's how that would look. You can see there are 4 special keywords being used here. Scenario just tells Cucumber we're about to describe an example that it can execute. Then you see the lines beginning with given, when, and then. Given is the context for the scenario. We're putting the system into a specific state, ready for the scenario to unfold. When is the action, something that happens to the system that will cause something else to happen, an outcome. Then is the outcome. It's the behavior we expect from the system when this action happens in this context. You'll notice we've omitted from our outcome anything about Lucy walking into Sean's store and making a purchase. Remember, gherkin is supposed to describe the behavior of the system, so it would be distracting to have that detail in our scenario. Each scenario has these 3 ingredients: a context, an action, and 1 or more outcomes. Together, they describe one single aspect of the behavior of the system. Now that we've translated our example into gherkin, we can automate it. The first file we're going to create is a feature file where we will write our first scenario. Create a file called shout.feature in the Shouty directory under Resources. Now that we have a scenario, it's time to run it. Switch back to the command prompt and run maven clean test. Maven will now download Cucumber, compile your code, and tell Cucumber to run the feature file. You'll see that Cucumber has found our feature file and read it back to us. We can see a summary of the results at the bottom. 3 steps, 1 scenario, all undefined. Let's run the scenario again from inside IntelliJ. Select the feature file and choose Run from the context menu. This will give you similar output. Undefined means Cucumber doesn't know what to do for any of the 3 steps we wrote in our gherkin scenario. It needs us to provide some step definitions. Step definitions translate from the plain language you use in gherkin into code. When Cucumber runs a step, it looks for a step definition that matches the text in the step. If it finds one, then it executes the code in the step definition. If it doesn't find one, well, you've just seen what happens. Cucumber helpfully prints out some code snippets that we can use as a basis for new step definitions. Let's copy those. We'll create a new class in the Shouty package where we'll paste those snippets. Make sure you create it under test and not main. Now IntelliJ is complaining that there are some unknown symbols. We need to add some import statements. Pressing Alt-Enter will do that for us. Once again, we're going to write the code we wish we had. So we need a way to ask Lucy what messages she's heard. And we also need to know what it was that Sean shouted. We can record what Sean shouts by storing it in an instance variable as the when step runs. This is a common pattern to use in Cucumber step definitions when you don't want to repeat the same test data in different parts of a scenario. Now we can use that value in the assertion check. We also need to add a messages heard method to our person class. Let's do that now. This is great. Whenever we do BDD, getting to our first failing test is a milestone. Seeing the test fail proves that it is capable of detecting errors in our code. Never trust an automated test that you haven't seen fail. Now all we have to do is write the code to make it pass. That's the easy bit. In this case, we're going to cheat. We have a one-line fix that will make the scenario pass. But it's not a particularly future-proof implementation. Can you guess what it is? I'll show you. There, I told you it wasn't very future-proof. Still, the fact that such a poor implementation can pass our test shows us that we need to work on our tests. A more comprehensive set of scenarios would force us to write a better implementation. This is the essence of behavior-driven development. Examples of behavior drive the development. So we know we need more scenarios and a better solution. Instead of writing a note on our to-do list, let's write another failing scenario. Now when we come back to this code, we can just run the tests and Cucumber will remind us what we need to do next. We're done for the day.